All right, hey everyone, how's it going? They started my timer, so I think I'm going to go ahead and start my talk. But before I get started, I just want to say it's been an amazing couple of days. I've had an amazing time, and I'm very grateful. Like, the organization of this conference has been amazing, from the food to the audiovisual to the speaker selection. I just want to take a moment. If we could give a round of applause to the organizers. It's been a truly amazing conference, an amazing experience for me personally. Thank you very much. I'm very honored to be here speaking to everyone here today. So my background, for my PhD thesis, I invented VR painting. So I created the first systems that allowed you to paint with your body in VR, which people today, we've all seen in commercial products like Tilt Brush. And I had this experience building this system. You can see a kind of a composite mixed reality picture of it, exhibitions I did at SIGGRAPH, some of the artworks that I made and other artists made. It was amazing. I worked with a group at BMW, the car design studio in Southern California. It was a technology that felt so good. I was motivated by making technology that just to feel better. But I saw these difficulties with this technology gaining traction. And I think it's something that we today are wondering a lot in the tech world. Everyone remembers the Oculus Kickstarter, how much optimism there was for VR, this technology that's so ridiculously cool, right? And here we are wondering, yeah, sure, VR is commercial, but it hasn't taken over the way mobile phones have. And we're asking our questions, why? And the point of my talk is to look at the future of technology. And in the almost 20 years since I did this work, I've continued to work with lots of emerging technologies, augmented reality, putting exotic lighting systems in cars and things of that nature. And I've continued to think about it. So this talk is kind of the culmination of my thoughts on this subject from that point to today. And I use the word oracle in my talk. And the word oracle comes from the Oracle of Delphi. The Greeks used to go and talk to someone who would predict the future. And we all want to find someone to tell us what the future will be. And in the tech world, we care a lot about it. And so what is our current oracle for predicting the future? And to sort of tell this story, I'm actually going to look back 50 years to Disneyland in Southern California, where I come from, had this thing called Tomorrowland. And they predicted the future of what would come. And thousands, millions of people came and saw this future in 1967. Of course, jetpacks were a big part of this future. They actually introduced Tomorrowland by having someone in a jetpack, and they said, in the future, we will all be going in jetpacks, right? And jetpacks are almost a cliche of the future that never happened. But the future that never happened in Tomorrowland was far deeper than that. They had a proposition about transportation, that there would be this people mover going through cities, a low-speed transit, kind of like a train you could get on and off. And of course, we don't see this in cities these days. Curiously enough, I was surprised to learn this, they actually had 360-degree cinema. They said 50 years ago, as many people have said in the past 2 or 3 years, wow, wouldn't movies be better if they were all around us all the time? Right? And this is completely technically feasible, but it still has yet to become mainstream. Why? Why? Right? Space life, this idea that we're living in space, humans in space. Right? What do we see today? Lots and lots of robots in space, not so many humans. So the things that Tomorrowland didn't have, they had hardly anything to do with computers, the really massive change we've seen in the past 50 years. Things like the internet, not predicted. Mobile phones, not predicted. Political and social forces like globalization, not predicted. You put all this together into something like Instagram, right? No one imagined that we'd all be sitting staring at pictures, of one another and sharing things as we all do, that everyone would be a television station the way we are with YouTube. These things weren't predicted, right? And then you look at who would have imagined the MMORPG, right? World of Warcraft. In fact, video games. No one even imagined video games. Things like the Mars rover, which I mentioned, or social patterns like remote work. DNA had just been discovered. Who would have expected things like 23andMe? And Tomorrowland wasn't particularly technically focused, but some of the movies at the time that dealt with technology, this is not the year 2001, this is the movie 2001, also from the late 60s. They had this idea of a single sentient robot that would be controlling the spaceship, one computer. What do we see today on the ISS? Over the International Space Station, we see over 50 computers running. We don't see a big monolithic machine. We see tons of machines. There are other ideas in science fiction of the time. A movie called Fantastic Voyage which had humans shrinking down to a microscopic size, nanoscale, to navigate through the human body. We also saw, this is one example of a trope we see over and over again, this idea of these sort of humanoid robots. Doctor Who and the Daleks were kind of these robots with arms that walked around and did things, something that people thought would be the future, right? So the heart of my talk is looking at things like science fiction. We look at science fiction to predict the future, but it hasn't been very accurate, right? The future of science fiction is a sensational future. It's one of feelings and fantasies. And we as humans, we're emotionally vulnerable to these feelings and fantasies. We look to that to say, that seems amazing. That must be what the future is. And we see that in contemporary science fiction. It's still going on today, right? You see movies, the one on the top left is from Aliens, right? A sort of humanoid robot gone amok, right? That's from the 80s, but we see more recent examples in Ex Machina of these humanoid robots that turn against us. We see an example in the movie Her. It doesn't have a face, but this operating system turns against its operator. And my thesis is that this fantasy that we all believe will come true has nothing to do with technological reality at all. It has more to do with mythology, things like the Frankenstein myth. So what is the Frankenstein myth? The myth of someone who makes a creature, and then the creature revolts against the creator. This is a deep, deep mythology, an archetype, if you will. It actually goes back to Adam and Eve, the story in the Garden of Eden. What was the story in the Garden of Eden? That God created Adam and Eve, and eventually they ate from the fruit of the tree of knowledge, and they rebelled against their creator. This is a deep archetype. We use these archetypes to predict the future, but they're not accurate. Also, we can look at virtual reality, right? In the top left is probably the oldest example, Lawnmower Man, a late 80s movie about VR. And the top right, we see a recent example, Ready Player One. And of course, The Matrix, right? This idea that we're going to just be transported into this magic land where it's like a dream. And I actually had this example in an Uber. The driver said, oh, yeah, I said I worked in virtual reality. And he said, oh, when will I be able to, just like a dream, float around and fly around like I do in dreams? I was like, never, because the VR idea there is more related to fantasies, like the fantasy of the Wizard of Oz, right, where you transported to a magical world that's entirely different. Alice in Wonderland, The Lion, Witch, and the Wardrobe. This has more to do with cultural mythology. Many people know the hero's journey. Joseph Campbell, I believe. This idea of the hero going and departing into a fantastic land. These stories we love to tell are rooted in that. And that's actually, think of the Odyssey, Homer, right? This idea of the hero going into these foreign lands. We want to see these dreams. And our desire to see these dreams, the feelings they might provide, cloud, that's the oracle we look to for the future, right? And there's another one, particularly in this interface space. And the interface space is most of what my talk is going to be centered on, because that's my specialty, is this idea, the Minority Report idea, or Tony Stark Iron Man idea, that we're going to be waving our hands and these pictures are going to be flying around and we're going to be controlling computers, not doing the kinds of things we do today, but, with this gestural power. That has more to do with the archetype of magic. The idea, and this is for me as a nerd that plays video games, I've cast a lot of spells in a lot of role-playing games. But even for people who aren't fantasy nerds, you see this in lots of religions, the idea of casting spells, voodoo, things of that nature. This archetype of magic is the oracle we use to predict the future. So my thesis in this talk is that this oracle is false, that we should stop believing in this oracle. And of course, that's not a very useful talk, right? To tell you, the things we look to are wrong. It doesn't give anyone, I'm trying to make this a positive talk, and this has been the thing that's challenged me for so many years. If it isn't our feelings and fantasies, if we can't trust our dreams to predict the future, what can we trust? So the thesis I present to you today is that instead of looking at sensational things to predict the future, we should look at informational things to predict the future. So what do I mean by informational? And this is a talk, it's actually a point that's difficult for me to make in regular audiences. But fortunately today, I'm here with my fellow engineers, and we can talk about it in the technical terms we all understand, bandwidth and latency. Many people know these terms, bandwidth and latency, from networking. Let's think of bandwidth and latency not from machine to machine, but bandwidth and latency from the human to the computer. And my thesis is that informational aspects predict what develops, not the sensational aspects. And this more granular, maybe somewhat mathematical way of looking at the world is a more accurate predictor. And so how do I justify this? Right? Oh, before I go into my justification, I'm going to give you an easy example of this from the recent past, and that is 3D TV. Everyone remembers about 5 years ago, 3D TV, it was all the rage. It was going to come, everyone was going to buy 3D TVs, everyone wanted to see 3D movies, and the press was saying at CES they were going crazy, the Consumer Electronics Show, about 3D TV. But 3D TV, as we all know, it is yet to, it's almost gone. People have almost forgotten about it at this point. So why did, and the current argument, if you look up Google, why did 3D TV fail? People say, oh, it was the glasses. No one wanted to wear glasses. Well, that doesn't make any sense to me. I mean, I had a Nintendo 3DS glasses-free auto-stereoscopic. It was one of the big advantages of this generation, no glasses. So why did 3D TV fail? And my somewhat technical explanation is actually looking at how the eye perceives depth. And if you look at the visual system, we actually have a whole slew of monocular depth cues. The cues that our brain uses, and this comes from psychophysics and neuroscience, the cues that we use to figure out depth, the vast majority of them are monocular, right? Like relative size, the relative size between things, perspective, motion parallax, even texture gradient. Take a checkerboard, tilt it, right? You can see that it recedes into space. And of course, lighting and shading is huge. And there are some binocular depth cues, but the one I've marked in yellow, binocular disparity, is the only one that 3D TV provided. So what's the net result of 3D TV? It turns out it doesn't actually add any information to our viewing experience. So we can look at an example. You all can look at this picture. You can see Tom Cruise is in front of the mountain, right? We know he's in the front. It's not like we put on our 3D glasses and all of a sudden we know where he is and we know where the spaceship is. You can tell this just by looking at this picture, the relationship of him to the spaceship. Here's another picture. Your brain very quickly, with the angular lines, the perspective lines, puts everything into space. Do you need 3D glasses to see that Tom Cruise is in front of the hill? No, you can just tell, right? The cue adds very little. So if we look at 3D TV, it's certainly sensational, no doubt sensational. Everyone who put the 3D glasses on for the first time said, wow, this is something I've never experienced before. And I bet most of the people in the room had that experience. But we've also all had the experience of watching several 3D movies and saying, I can barely tell it's in 3D. And man, the edges of the screen are fuzzy. And all the very storytelling and the composition we know from like Renaissance painting with the edges of the screen kind of diminishes. There's really not an informational advantage to 3D TV. And this is why we've actually seen, believe it or not, 3D movies have come and gone many times. In the early 20s, there's a period from the early 20s to the mid-30s. There are a ton of experiments and shorts in 3D movies. They didn't really take. In the mid-50s, Hollywood went crazy with movies like Creature from the Black Lagoon in 3D. We've all seen the famous photo of people in the movie theater with the anaglyph glasses on. And yeah, people got excited, but they quickly moved on. In the around early 80s, more 3D movies, and we all know Avatar. 3D movies come every 25 years, and then they go, because we're all prey to the sensational hype that it'll be awesome. And then as we experience, we realize we're not getting anything new from the 3D movies. And so with that in mind, and hopefully a better understanding of what informational is, I'm going to now proceed to talk about the history of the development of computer input devices. And we're going to focus on the past a bit, sort of establish this way of thinking. And then we're going to look to the present and the future to see how all this happens. And so at the past, let's look at this computer from the 80s. What do we see here? First of all, we see a lot of computer, right? These days, computers have gotten the size of a deck of playing cards. We also see a sort of small screen that isn't very high resolution. We all know screens have gotten higher resolution. And of course, there's a huge informational advantage to a higher resolution screen. More pixels allows us to see more information. In terms of the bandwidth of what can be communicated to a human, it's much higher in a higher resolution screen. But we see this funny thing at the bottom of the picture, which is the keyboard and the mouse. And those have changed very little. You could go to offices today and see the same thing. And the question is, why? Why do we still have the keyboard and mouse? And I don't think, no one seems to like the keyboard and mouse. It isn't because it's our sci-fi dream. right? In fact, the mouse, when it was first invented, this is no one's fantasy of an input device. Someone just thought, hey, I can measure the X and Y axis directly with these wheels, and maybe I can use this to control a point on the screen. And it seemed to work very well. This was no one's dream. What did people dream of in terms of 2D input on a computer? Well, one of the things they dreamt of was the pen. It was actually developed 10 years before the mouse. And it didn't take off, but it was everyone's dream. Why is the pen such a dream? Because, well, prior to 1955, the pen was the best way to interact with a 2D surface. If you look at handwriting, if you look at painting, all the time that humans, it dates back to cuneiform, thousands of years, when humans need to do something on a surface, mark a surface, annotate it any way, there was something shaped like this pen. This was the fantasy. For those of us fortunate to be alive in the 90s, like myself, we remember a time when the pen was proposed as the future of computing. Everyone remembers this time, right? There was this thing called the Palm Pilot. It was really popular. And at the time, people were saying, hey, there's a technological change called optical character recognition. Now we have the computational power to recognize handwriting. Finally, we can get rid of this horrible mouse, this weird box that lives on our table. We can go to the fantasy of being able to do what's natural for humans, right? Write with the pen. It was the same time that I was thinking it's just natural for humans to paint in space with VR, right? And in fact, there was a whole Windows tablet PC craze going on where you would, there were these tablet PCs, and the idea is you could just get rid of the keyboard most of the time. You could do everything with a pen. If you needed to write, you could write on the screen. And voila, we would have our fantastic future where we could use this more natural, more human way of interacting with computers and get rid of the keyboard and mouse. But there's a subtle informational bias here. The handwriting studies show that handwriting is slower than typing. Typing, as unnatural and awkward as it is, allows us to enter text about 50% faster than handwriting. So it doesn't matter how good the optical character recognition is, the typing is going to beat, the dream of using the pen. And everyone in this room was alive in 2013 and remembering a similar thing that happened with touchscreens. What happened with touchscreens? The iPhone came out, and man, it feels good to use an iPhone, doesn't it? And so we thought all of computing is going to go this way. All of our PCs are going to be touch. And there was a line of PCs, the HP TouchSmarts, all touch-based. Windows 8. Anyone remember Windows 8? How great was that, right? Not very great, because they shifted everything to touch. And what's happened with this idea of touch-based Windows? It didn't take off, right? In fact, if we look at a product like the Microsoft Surface, the touchscreen has gotten less and less and less important in the product line, and more important in the product line has been the idea of a thing with a trackpad and a mouse that allow us to interact in this way, right? Why do we have to deal with a keyboard and mouse? Why can't they go away? Why can't we invent anything better, right? So now we're going to do a bit of an informational breakdown, and we're going to look at the bandwidth and latency aspects of the mouse. What do we have with the mouse? High precision 2D points. The fact that you can input with very high precision is a bandwidth factor. The mouse also has discrete events. And discrete events, as we know, anyone who programs know that tokenizing events, calling functions, sending packets of information, the idea that we can tokenize things, there's not a continuous stream, these basically button clicks is what I mean by discrete events. They're crucial to being able to complete tasks on a computer. The mouse is amazing with discrete events. Our hand just rests on the button and can tap it. Mice aren't very good at dragging, right? It's kind of awkward to drag. But the thing that we see with the mouse, and this is the latency factor with the mouse, there's a very fast swap to the keyboard. So as you're sitting in front of your computer, you can type, you can use your mouse, you can go back and forth. If you're sitting at a desk, it's very low latency to swap from mousing to typing. And this is why we continue to use the mouse for all the most demanding computing tasks we do, right? If you want to play a MOBA or any really complex computer game, real-time strategy games, people will use a mouse for that because the precisional advantage. It's just not as good. You can't play as rich a game with touch. And touchscreen MOBAs do exist. They're just not as rich or fast as mouse-based MOBAs. Things like spreadsheets entering information to a spreadsheet. You have this huge grid of numbers. You need to be able to access these points with precision and go back and forth to typing. 3D modeling, in terms of texturing and all the highly technical rigging, character rigging aspects of 3D modeling are based on a mouse. And of course, as we all know, programming. You want to have a huge text buffer, and you want to use Sublime. You want to be able to put your cursor exactly where you want to very quickly. For this, we don't accept anything less. We can look at touch. What are the informational aspects of touch? Well, touch is far lower precision, the points. You still have great discrete events. Touch is great at dragging. And we do have the possibility of swapping to the keyboard. And that's why we see in touch many things come along, more simplified applications, Uber, email, Candy Crush, right? These kinds of things that are not as demanding and you're not having as long sessions are great for touch. And we're happy to use touchscreens for this. We don't feel the need for anything more than what we have with touchscreens. And what do we see with the pen? The pen is a kind of funny, interesting hybrid thing. We have a mid-level of precision. So we don't have high precision like we do with the mouse, but we have better precision than the touchscreen. Discrete events are a little weird with the pen. You know, you get the pen down, but it's harder to separate with a button press, but you can do it. The real advantage of the pen is it's really strong at dragging, right? You can do great drag events with a lot of precision. It's also, the pen has a downside in terms of latency. It's not easy to swap to the keyboard. If you're using a pen, you can get a little better at this, but you putting the pen down, typing, etc. For more serious tasks, it doesn't work that well. Pens on mobile phones are even worse, as we know. Having to take the pen out and put it back in every time you have to input spatial information, like we do with Palm Pilot, is a drag, right? And that's where do we see the pen? We see the pen. It still exists, right? It's not like the pen doesn't exist at all. It's great for art apps, right? If you want to paint. If you want to use something like ZBrush, the pen is wonderful for that, and these things typically require very little typing. So it's not like pen doesn't exist. It's cheap. It's ubiquitous. It just hasn't dominated all of computing. That's the history of the pen. So you can basically see this breakdown of the informational aspects of the input devices. With mice, we have high precision, and it's great for long-duration sessions. As a little footnote, we have the trackpad, right? Similar to the mouse in terms of precision, more for a mid to short duration thing, right? We all like, if we're going to sit down for an hour, we'll bother to take our mouse out of our bag and plug it in, right? But for a short session, we're me setting up these slides, I'm happy to use a trackpad. The touch, great for low precision, short duration actions like we do on our mobile phone. The pen, the main advantage is the precision of the drag, and that's why we see the pen only existing there. So that's the history of the past, and that's, in terms of this theory about information versus sensation, that's my rationale from distant history. Now let's look at VR. Let's look at the informational aspects of VR. What do we get with it? First, and by VR, I mean basically like the Oculus DK2, the Vive, the new Oculus, all the new stuff that's coming out. They have two 6 degree of freedom input devices, one in either hand, and they also track your head. We have great discrete events. Buttons on these controllers allow easy discrete events like we do with the mouse. They're also great at dragging, right? So we see, in terms of input, there's a lot of informational advantage. We can input a lot more information with our hands. But we have some limitations in terms of what we see. They're lower resolution. We have 1600 by 1400 on each eye. And also, you really only, like in the center, the sort of foveal area, there's not nearly as much resolution as when I look at a screen. And then there's another point, so the information to the eyes is a little less. And then there's this latency issue with VR. It's a total experience. If you want to do a VR and stop doing a VR, you have to put all this gear on and take it off, right? So it's a big latency to initiate an interaction or stop doing an interaction, which in some ways limits its interoperability with other aspects of life. And now, that's the sort of characteristics. Now let's look at what's actually happened in VR, like some of the fantasies that people have had in VR. One of the fantasies, as you can see on the left, is this idea that instead of using these desktops, we could have as many screens as you want surrounding you in space. And the idea, this has been built, things like big screen in VR do this. It turns out this is not a good way to code. Why? Right? Well, the reason is mainly the information of the vision. That floating panel of text gives you very small, in that 1600 by 400, what is the resolution of that text buffer there? It's maybe 400 by 400. It's not really good at seeing code. The other thing about it is that we already have a great solution, a very low latency solution in desktop computers for swapping between one window and another. It's called Alt-Tab. It's actually easy, right, for us to switch between screens. We have these things called spaces, and all the Unices have their Linux, they have the fancy ways of doing it, right? It's actually pretty easy to manage multiple desktops on a Windows machine or a Mac or a Linux box. And so the informational advantage of these screens floating in space is very low. So as sensational and cool as it may be, the informational properties don't allow us to be more productive. They don't allow us to communicate to the machine more rapidly. So this is why these things haven't taken off, right? Also, there's this idea, a very persistent idea that I probably think most people believe in. Everyone tells me they believe in this thing called the Metaverse, that in the future, just like Ready Player One, everyone's going to hang out all the time in VR and socialize there, right? On the left, we see VR chat. A really awesome, I think the best implementation of this Metaverse idea. And VR chat, don't get me wrong, it's popular. Many people do it. They have a lot of fun with it. It's a great way to have fun. But it's not a great way to communicate. What do people do instead? We text. How many people, raise your hand if you sent a text message today, right? We got pretty much everyone. And what do we see in texting? It's a great way to exchange information. We send 3 letters here and there, SMH, I'm shaking my head. We use emoji. We can actually communicate with a high degree of emotional bandwidth with one another. And even more importantly, texting is low latency. I can, in the middle of this talk, receive a text and give a text, and it doesn't interrupt my flow of life very more. I don't have to strap on a headset in order to communicate with someone. And so texting, and how many sci-fi books talk about text messaging? Very few. How many sci-fi movies, how many exhibits about the future talk about texting? Very few. It's no one's dream. It's not cool, but it works. And so this illustrates my thesis. Informational aspects dominate the sensational aspects. We can talk about Minecraft in VR, right? Everyone said, oh my God, I was actually at Minecon when they announced Minecraft in VR. The whole crowd was, oh, finally, a dream come true. I'll be able to step inside my Minecraft world and really experience it. But it's been built, and it's not really getting that much traction. But what do we see succeeding in VR gaming? We see games like Space Pirate Trainer doing extremely well. And what does it allow you to do? Dual wield. You get 2 guns. And unlike the standard first-person shooter, you actually get 2 vectors. You use those 6 degree of freedom controllers to specify 2 vectors. It allows you to have a gameplay experience you couldn't have any other way. So yes, granted, it's sensational to be in this world, but more importantly, you can actually conduct a different kind of gameplay than you could. Whereas Minecraft in VR, it's the same gameplay paradigm under the hood. We also see this idea that you're going to be flying, these flight simulators, right? I've been to many a VR conference, and you see these curious people strapped in these devices flying, and they're trying to put together the whole dream of flying and everything, right? And, those are a great novelty, right? They're certainly fun to do once. But they're kind of similar to the arcade games. Like everyone's seen the arcade game where you get to really ride on the motorcycle or the skateboard or in the cockpit, right? It's fun, but it doesn't actually change your gameplay. What we see actually happening is flying games are still pretty standard on the flat screen. We even see games like Elite Dangerous. People got excited about that in the days of the Oculus DK2. But it didn't really take off. Why? Because most of what goes into a flight game are these information panels, kind of like you can see the text panels floating and all the buttons and controls. You get a far more rich data kind of control in a more standard interface. Meanwhile, the ability to look around doesn't affect you that much. And the 6 degree of freedom controllers don't help that much. So these games haven't really left VR. And of course, in the creative space, a big idea that a lot of people bought into, hook, line, and sinker, was that this idea of these visualizations in VR, similar with 360 video, to be able to see a 360 video walkthrough of a space, that this would be the killer app of VR. And granted, dozens, perhaps hundreds of companies have built this, and it's making a very minor dent in the world of architecture, what we see on the left. Why? Talented architects, they can look at a CAD screen and imagine it. If you want to do a client presentation, it's better to show the client still pictures anyway. But where have we seen creative benefit in the VR space? It's these painting systems like Tilt Brush. Why? Because they allow you to put strokes in space. Kind of in the same way that the pen is informationally different than the mouse, and the pen in 2D allows a different form of art, the pen in 3D allows a new kind of art. Has Tilt Brush replaced the standard rendering pipeline, texturing pipeline, rigging, all these non-spatial things haven't taken off in VR because the mouse is better. But this particular thing that's sensational and uses a new kind of information has found a home in VR. So this is why we see VR, somewhat like things like the pen, finding a home, a permanent home in the world of computing, but not taking over everything. Because for other tasks, there are better ways. There are better ways to communicate the information. And this also explains the future of the hand. And people come up to me all the time, and they're like, you know, like a Minority Report, when will I be able to just use the computer like this? So let's look at the informational properties of the hand. What do you get? You get a skeletal approximation, which is awesome for things that need a skeletal approximation. But what is your point in space that you're controlling? What is the locus of control with the hand? It's not evident. The perhaps worst thing about the hand, the biggest weakness, is the total lack of discrete events. Where are button presses? And I know I've seen the videos, you know, the Leap Motion, they figured out a way where it's like if you pass through a certain point in space, you trigger a button, right? Similar to some of these Kinect games where it's like, yeah, this is not a button press, this is a button press. But the discrete events are very difficult. They're not fundamental to the input mechanism. It does have a fast swap to keyboard, which is great. But this is why we haven't really seen much takeoff with the hands. We only see demos, right, that you can use novelties for a short period of time. The best one I've seen is Fruit Ninja, right? But even with Fruit Ninja, it's fun, but it's better to play on a mobile phone because the precision of the gesture and the 2D point specification is just better. I have more control of the gameplay experience. The gameplay experience is not so much how it feels as the kind of information I can communicate, the way in which I can participate in the abstract world of the game. And here we can look at some other, maybe this is a bit of a recent pass, we can look at smartphone AR. So what do we see with smartphone AR? There's no spatial input whatsoever, right? There are no discrete events. It's difficult to transition into out to. The thing you do get with smartphone AR is all the touch UI of typical smartphones is still there. But the AR itself doesn't really have any interaction. And so that's why we see things like we see here. On the left, we see an AR application, which basically allows you, and people thought this was really cool. Granted, it's like Harry Potter on steroids, right? You can take your phone, you can point it at a picture, some 3D model pops out, and allows you to see 3D models on top of cards. And this is kind of like the limitation of, say, 4 years ago consumer AR. On the right, we see something far less exciting and dreamlike, which is a 3D model viewer, which shows you a 3D model that you can then spin and rotate and see, you know, you can see all sides of the 3D model. So if you want to see all the sides of the 3D model on the left with the AR, what do? You have to walk around the card or rotate the card. It's actually a very slow way to access different sides of the 3D model. If you want to see underneath the 3D model, you have no way to do it. And of course, the display takes up much of the screen. It's not natural to have more standard buttons. And what do we see on the right? On the right, we see the basic 3D model viewer actually allows you to access the information and communicate with the machine better and see the data better. And so that's why no matter how many of these come out, they haven't really taken off because it's not the best way to do the task. We can see a similar thing with Minecraft. Of course, Minecraft has been taken to AR, and this is the ARKit version of Minecraft, which is like you can take any surface, you can take your phone, and your Minecraft world appears on it. What could be better than that, right? Super awesome, super cool. And there are many game ideas that are sort of like this, which is like take your 3D game world and kind of plonk it on reality. And the great advantages to the ARKit technology in that it doesn't require a card or a marker of any kind, right? So there's a loosening of the constraints of where you can have your AR. But what we see doing very well is typical iPhone Minecraft. We see here the screen is entirely dominated with your imaginary world. Also, if you want to move around the world, you can move. You don't have to physically walk around to move around your AR world as you have to do, your Minecraft world, as you have to do in AR. And so that's why these things we see that are so cool don't actually take off and become permanent parts, dominant parts of the computing ecosystem. There's another idea in AR that comes up over and over again, which is this idea, and we see this in lots of movies, lots of robots and stuff have this kind of visor you can put on that shows you things in the world. And so that's what we see on the left. You're walking down the street. It's like, oh, here's a bar. Here's a train station, On the right, we see a more typical interface, Yelp, a popular app in my country for finding things. And what I've seen happen in the market is, so this idea on the left was actually first released in 2010. This company called Urban Spoon built it. And I tried using it, and it works very well. It was actually re-released more recently by Yelp itself, a way of experiencing the world in AR. And the problem with it is, as cool as it is, if you look at the map on the right, it actually allows a far richer display of information. On the map on the right, I can actually see all kinds of locations that are not in my field of view. And we can use this language of graphic design to communicate things, right? I get a very high density. I can quickly get these pages with reviews and comments, things that aren't spatial at all, kind of get interleaved with the spatial information in a great way, and it's a far more rich informational experience. So this is why in the iPhone world, people try again and again to do this restaurant thing with the map, but the implementations are great, but the utilization is very low, because even though it's sensational, it doesn't actually convey information at a higher bandwidth to humans than the existing solution, which rests more on 2D graphic design and our history of cartography and map making. So when we look at the future, so many people talk about the future of AR, and they're like, this is what it's going to be. Put on your HoloLens, your Magic Leap, and you can have the 3D model really in the room with you. And they make sexy pictures like this of that future. And my argument is that I'm not going to say it'll never happen, because it already has happened, right? But it'll be a footnote in a minor part of our computing experience. And this dates, for the very reasons that the interface on the right is just a better way than the interface on the left to extract information. So the goggles don't change that fundamental aspect, right, of binding someone to the physical world actually cripples them. It actually limits their ability to peruse the information, because we're locked in this physical world mimesis kind of space. Does that mean that I don't think there's a future for these glasses? No, I think there's actually quite a strong future for these glasses. Why? Because we actually are all suffering from a problem which glasses could fix. And the problem is the latency problem. Every time we want to use our smartphone when we're walking down the street, we have to take it out of our pocket and put it back in. That is latency. You get a text message, you actually have to take it out and put it back in. And many people have observed that the glasses allow, you don't have to take the phone out of your pocket to see something, right? And so there's some real hope for glasses. But we have to realize that the hope for glasses is counterbalanced by their disadvantages. One being resolution, right? Much smaller resolution screens means you can get much less information into your eye. And if you've tried these early AR products, Google Glass is an example of a more text-based experience. It's a very small amount of information you can see. And if you've tried a HoloLens or a Magic Leap, you'll see they're very small and low resolution. So there's definitely potential by putting the screen on the face to remove this latency of interaction. But we have to counterbalance that with something else, which is input. And a lot of people look at AR and they think about how great it could be visually. But let's think about input. How do I input information? How do I click a button on these glasses? Do I have a pointer floating in space? Do we have some natural hand thing? Right? As I've kind of mentioned, with a natural hand, what is the button press? How do I say that that's the button that I want and not have it think that I'm moving my hand in some other way? So if people are looking for very difficult and very meaningful problems to solve in AR, I think people should look less to figuring out how to make the screens and more about how we can use our hands to input information to an AR device while we're walking down the street. Because this latency problem, now that we're at this plateau of smartphones, and it's a problem that sci-fi never thought we'd have, right? Because sci-fi never predicted smartphones. But now that we have them, they work so well. How can we make it so human can interact while walking down the street in some meaningful way? And we need to have the things that we have already, typing, button presses, basic spatial input, just to get parity with what we already have. A lot of people talk about AR, this idea of things in the factory. There's this floating screen idea, right, which is a very strange reason to wear one of these headsets. Anyone who's actually been in a factory knows that computer screens and monitors are everywhere, and that people can have tablets that are far higher resolution than this floating screen, and also can receive button presses. So this idea of like, oh, you could just like have this screen floating is very limited, right? And then people talk about putting markers and labels on things in the everyday world. And that requires this thing called object recognition. And here you can see an example of some basic object recognition algorithms running. It's certainly a big part of AR to be able to label it. But my prediction is that the AR of the glasses is going to be of marginal utility to the human species. It's not going to be the next internet. If we want to look for the next internet with AR, we need to forget about the glasses and look at the information that's being exchanged. Realize that the average human, I can look in this room, I can identify most of what's here, but computers are only now getting the ability to see what's in the world. The ability of computers, even without a human interface, to see what's in the world is the real potential of AR technology. And I can give a kind of pedestrian example with Uber, right? Think about Uber. How powerful is it to know where I am on the map with GPS? That's one thing. What Uber allows computers to do, it allows our tech stacks to know where we are at any point in time and connect us with drivers. So that small GPS is just a small piece of information about the external world that can be processed by a computer. And so as we see object recognition grow, we're going to see a big growth in potential new economies because computers know what's in the environment. And so that's more the spot to look. So if you want to talk about a vision for the future, my vision for the future, I think this Ready Player One idea of being immersed in a metaverse, a single virtual world, is extremely unlikely. Just look at the evidence. How many virtual worlds do we hang out in? You might play some video games. You might play some MMOs. You might play Fortnite. You might use Facebook. You might use Instagram. The reality is there's no dominant single network that we all participate in. This idea that we're going to put on this suit and be in it all the time goes against all the evidence that we're seeing. We see humans using a variety of things. What we actually see happening is the input device that best fits the informational context of the task that needs to be executed is the one that we use. So of course we still use keyboards all the time if you have to do a lot of text entry. Of course we use mice all the time if you need to do high precision input. And yes, we'll see AR goggles, we'll see voice, right? I haven't gone much into voice, it's kind of a whole other subject. Voice is good for some things, but not everything. But in all these cases, we'll be looking at the sort of top-level bandwidth and latency of the human communicating with the system to govern what actually develops. And I think this point about information exchange as opposed to sensation is especially important when we look at brain interfaces, right? Many people, when you read these articles, they say, oh, and then there's the brain, right? The final point of computer interface will be the brain. We'll just jack directly in, right? And nothing else will exist. And the reason people say that is they say, look at our retinas. Look how few cells there are in the retina, right? We can only really send information, there are like 1 million retinal ganglia that we can send information to. What if we could connect computers to all of the brain? Wouldn't that be awesome? How much more stuff could we do to communicate and put things into the brain? Well, it turns out our brains, the 30% you've been wondering about for the last 30 seconds, that is the percent of your brain that's dedicated to visual processing. That small little patch of retina, it takes 30% of our brain extracts information from that, right? So if we are going to like beam into our brains in different ways, my question is, what part of the brain will process the information? This is why vision is so powerful in humans, because we have such a rich system for reading things, even in simple 2D displays, right? This is why newspapers and magazines and all the ways, websites, we can consume tons and tons of information. And if we add the motor cortex and the way we put out information, it just turns out our brains are only so big. And we actually are already tapping into a huge chunk of our brains. So I'm not here to say, again, I think brain interfaces are on this as well. I'm not here to say it'll never happen, but it's currently in these limited cases where people have difficulty interacting or it's to substitute something else. Like we already are utilizing a ton of our brains when we work with computers, and so it seems unlikely that we're just going to completely switch to this brain-based way of working when we're already accessing and exchanging information with our brains with the mechanisms we have right now. So to kind of summarize, if you want to look at an oracle for the future, and this is what I encourage everyone to do, is to take those fantasies and step back from them a little bit, right? Don't pray to the oracle of sensation when trying to figure out what will happen next. And this is maybe not, it's not what the popular mind wants to hear. It's not what the average person wants to hear. And we all need to realize there are times where the sensational is valuable. Are you pitching to a venture capitalist, right? Are you writing a press release? Are you trying to do your ICO or whatever you're trying to do? If you're trying to market your work, by all means, go for the sensational stuff. People eat it up, right? Sell that to people if you need to sell things to people. But for us as engineers who develop technology and need to understand at a deeper level how it moves, to me, these informational aspects are the way of both understanding the past, the deep past, why we're stuck with the mouse, the more recent past, why VR is here but not taking over everything, and also a way for us to understand the future. And this is when it comes to you, right? When you're trying to build your futures, when you're trying to work on the edge of technology, always remember information and look at information, and don't be one of the people in the graveyard of startups who've gone for something sensational because it's cool and sensational. And also, for those of you who have to convince business people in suits of things, I've actually found with personal experience this language about sensational versus informational works very well with the kind of business types you have to deal with from day to day. So I hope this language has been useful in a way to understand technology. And for those of you who look at what I'm saying and have kind of understood it already, who knew this kind of thing already, and I think some people who've been in the field for a while must have a sense of this, I hope this information has been useful to you. Just in terms of a language and a way of thinking about it, and perhaps some other examples. That's about it for my talk. You can look me up, find me on LinkedIn. I love to be in touch with people. You can find out about my company there, but also if you're interested in more of my thinking, I post on Medium pretty regularly. I have a series on voice and another one on consciousness that are going on. Check it out if you're interested in hearing more stuff like this. Thank you very much.